Hi everybody. This video today is going to talk about three variable systems. So that's what we've been talking about for a while, but we're going to talk about situations where we might have no solution or infinite solutions. And so to do this, what I'm going to do is, this is a worksheet that we're going to do, but I'm going to just work through a couple of examples for you and see what's going to happen with these examples. So let's start off with number 3. I'm going to label this first one R1, R2, and then R3. And I want to look and see how could I do some elimination method. I just think that elimination method, for the way these are set up, elimination method is going to work out well. And so as I look at R3, well, first of all, I'm looking at the z's. The z's catch my attention because there's a z and a negative z, so those will be easy to cancel. And then a 4z, which should just be 4 times, and that might be easy also. You could also do the y's, because the y's are pretty easy, 6 and 3 and 3. I'm just going to do the z's because that's how I had thought about doing it. So if I take R1 plus R2, and I'm just going to add these kind of in my head. So negative 2x plus x is negative x, 6y, and 14. I'm now going to call that R5. So that's, for me, that's going to be R5. Then what happened was I got rid of the z. I want to get rid of a z again. And so perhaps I could take 4 times R2 and multiply that and get rid of that with R3. So I'm going to take 4 times R2. So I take 4 times R2, that gives me 4x plus 12y minus 4z is negative 4. And now I'm going to add that to the line below, that's R3. And so if I add these two together, I'm going to get a negative x plus 6y. My z's cancel out, and this comes out to be negative 20. I'm going to call that, I call that R5. I'll call this R4. I skipped R4 in my numbering. That's okay. So now I have these two that I can also add together. But I need one of them to be negative and one to be positive. So maybe I want to change signs on my R4. So I'm going to go positive, negative, positive. I just multiplied everything by negative 1. If I multiply by everything by negative 1, I get this. Now, if I take R4 plus R5, and again, I'm just going to kind of do that in my head. So negative x plus x is 0. That one drops off. Good. 6y and negative 6y, that also drops off. That's kind of odd. So I have 0 plus 0 is equal to 34. Well, that means it's no solution. So you know that when you get an answer like that, 0 equals 34, that means no solution. It also means no solution in these situations. So that is a no solution problem. Let me go back and explain that a little bit more. Let me show you a diagram that comes from our Big Ideas textbook. So this is from the Big Ideas textbook, the Algebra 2 textbook. And so they go through and talk about some things. And we've talked about some of this in class, but a solution is an ordered triple. So instead of an ordered pair, we've ordered triples. And this is whatever makes the situation true. Now, up to this point, we've been doing, well, all of these where I have only one solution. That is, imagine that the kind of that pinkish one, the blue, and the green, imagine those are all of the systems, because, the equations. Because an equation, if it has 3 points, it makes a plane. So these equations are no longer lines, these are planes. And so where these 3 planes meet, that is the solution to the system, because that point is where they will all meet together. So for instance, on this worksheet, if I graphed these 3 planes, they would all hit each other at this particular point in space. That's what's going on. So that's what we've done so far, is where they all 3 hit each other. But they don't all 3 always hit each other. So the one that we just looked at and worked out on the worksheet a second ago was this case of no solution. Maybe the blue hits the gray, or the blue hits the green, and the green hits the pink, and the pink hit, but they never all 3 hit each other, because on this one they all 3 hit each other. Or maybe there's like this, but again, they don't all 3 hit each other. Or maybe they look like this, where they don't all 3 hit each other. In any one of those situations, that would be a no solution. But maybe we have a situation like this, where they do all hit each other, but it's not a single point. This time when they all hit each other, it's a line. And for our class, we're just going to say infinite solutions. In some algebra classes, you would go ahead and solve and find out what that equation is. But for this class, we're just not going to do that. That's too complex for Algebra 2. In a college algebra, you might do that. But anyway, I wanted to show you what these possible situations are. And they might hit in one place, they might hit in an infinite number of places, or they might hit not at all, where all three of them don't hit each other. So back here on the example that we were just working with, example number 3, I don't honestly know how these would look in a graph, but what I do know is that all three of them are not going to hit each other. It is going to be one of those cases where they don't hit, maybe they're parallel, maybe that little triangle shape, whatever, but they are not going to all hit each other. So if it is a no solution problem, it's like that. It's like 0 equals 3. We know that that means no solution. If it comes out where you're working out a problem and you get something like 0 equals 0 or 3 equals 3, that means you have an infinite solution situation. Let's go down and look at the very last problem. The only thing new in this problem is that it's in table form. But what we need to understand is that tables can be translated into equations. So for instance, this first line, we could make seniors be the x, adults be the y's, and a child be the z. And so we would have 5x plus 10y plus 12z is equal to 310. And we could do that for each line. So this would be 5x plus 5y plus 4z. And we will set that equal to 155. The last one's going to be 4x plus 2y plus 3z is equal to 92. And then we would just go ahead and solve it like we normally would. Okay, we will work some more on this worksheet in class tomorrow.